Now we'll see how to convert ER diagrams into relational tables. We know that, so we have to convert our ER diagrams to relational tables. Then only we can store them in our DBMS, right? So how to do that process? It is again automatic process. We'll see. So finally you remember one thing. Every detail of ER diagram to be somehow should be captured. First of all, example, see we have entities and relationship, right? Then every entity generally will be created as table. So create a table for student, create a table for enroll, create a table for course. Now how to create a table for student is straightforward. Create student table, and in that this SID comma SName should be attribute names, that means fields. So here this underline says that, so SID is a candidate key, that means we can declare SID as primary key. Now that's it. So this is about student table. Similarly in course table, so make CID primary key. So we are maintaining this condition. Now course name and fee are just simple ordinary attributes. Now we see the relationship. These two are straightforward, very easy. Now when it comes to enroll, so enroll usually can be captured by taking student information and course information, right? And a descriptive attribute type. So type is generally online or offline. So it's a property of it's not a property of student, it's not a property of course. It's a property of enroll relationship when a student takes a course, correct? So typical data will be like this. So a student, correct? He will take a course, right? So and type of that course is maybe online or offline, correct? Online, otherwise offline. So this is the relationship data, right? To record it, so one way is take all the attributes of student, all the attributes of course, you can write this kind of data, right? Student ID, student name and type, course ID, course name, fee. But slowly you will understand that this is unnecessary. Why student name is required? Correct, already student name is stored in student table, right? It's a student property. Since here we want to just say that some student is enrolling, one unique identifier from student is enough, right? Similarly course name, fee is entire thing is not required, that will be covered in course. So here finally in enroll we take student ID to uniquely represent student object, and to uniquely represent course object we take course ID. That's it. Along with this attribute, what is a descriptive attribute, we make a table that is nothing but a table for enroll. Understand? So what is a primary key for this table then? Simple. In this kind of relationship generally, so here student ID, you ask yourself, student ID, is it unique? No, because a student can take, it depends on the key. I can say that mapping cardinality. Every student is taking multiple courses and every course is taken by multiple students. Since this relationship type is many to many, so what we have to do is student ID has to be repeated, course ID has to be repeated, but one student takes one course only one time, correct? So that's why if that is the condition, then I can make student ID, course ID primary key, correct? So finally you remember from now onwards, whenever a relationship is many to many, then in that table, so we take primary key of the left side. I am assuming that there are two relationships, two entities. So entity 1, entity 2. In entity 1 take the primary key, in entity 2 take the primary key and take the descriptive attributes and create the table, and the combination of primary key of left side and primary key of right side should be the primary key of this table. In that way we can create a table for this kind of relationships, right? Now we have to cover one more thing, that is, sir, how we capture participation constraints? Can we capture participation constraints? We have to see. And can we capture one to one cardinality, otherwise second one to many, many to one? How to have, for that do we have a different creation of the tables? We will see. So this is a basic model. So slowly we understand that sometimes we require only 2 tables rather than 3 tables. We'll understand that. But for this requirement, whenever relationship type is many to many, then we require 3 tables. One is for definitely student, one is for course, and we require another table enroll. Okay. So why we require another table? Why can't we write that enroll information in student? We will see. What happens if you write enroll information in student? So this will happen. Let's try to write it. So what I do is I write like this: student ID, Student name is nothing but student table, correct? Along with that, what I do is I try to write enroll information. What is that? Course ID and type. This is called moving the relation to one entity, like participating entity. If you do that, what happens is, example, one student takes 100 courses. So there is a greedy student, he wants to take 100 students, 100 courses like C, C++, whatever the variation of the course comes, he will join. C minus, C minus minus, everything. Then in this one, if multiple courses if he takes, unnecessarily we have to repeat this information like one Raju, one Raju, one Raju. Whenever you repeat the information, you get anomalies. Please remember, in normalization I taught you, whenever you repeat the information, you get at least one anomaly, that is updation anomaly, correct? So that's why we should avoid it, and we are wasting lot of space. Now here also C, C++, C minus 1, of course type is compulsory, but if you, that's it. So finally, unnecessarily you are wasting space for S name and you are going to get the anomalies. This is not the right design. Correct. So we don't do that. Similarly, try to move this enroll to course and try to create only one table rather than three tables. That means two tables. So rather than enroll separate, course separate, we are doing course and enroll in one time, in one thing, like course enroll. Is it possible or not, we'll see, and what is the problem, we will see. So course ID, course name, let's take fee, followed by, just add student ID, comma, type. If you do that, what happens, we'll see. Again, if a course C, which is very popular, if it is taken by 5,000 students, then you will be recording the data like this. C, C, C. Why 5,000 times you are writing C? Because there are 5,000 students. Let's say they took this course 5,000. Then unnecessarily 5,000 times you are writing course name, correct? And fee everywhere. You are wasting the space. Second one, you are repeating the data. When there is a repetition of data, all the anomalies will come into the picture. Insertion anomaly, deletion anomaly, updation anomaly. Essentially, definitely there is a updation anomaly, you see, because there is a redundancy, right? To avoid the anomalies, again we have to do the normalization. Then automatically your tables will be splitted into again three parts. Correct. So that's why when you are converting from ER diagram to relational tables, then better you divide it into three parts. If you merge these two into one also, you get normalization problems, and in later in normalization, however, we have to divide it again. Correct. So finally what I want to say is, this table can be divided into three parts. That means if this I can say if this ER diagram is converted into tables, then the number of tables are essentially equal to 3. Understand? Now we will see second kind of problems. That means, what if the cardinality is 1 to many and many to 1 and 1 to 1, everything one by one we'll see. Let's see these two cases. This one is 1 to many relationship. This one, let's say many to 1. So whenever you have 1 to many, so how to convert that into relational tables, we'll see. Generally we can create three tables. That is plan number 1 as usual. So faculty ID is a unique identification number. So make it primary key in that faculty table. Create faculty table, guides table, student table. So in student ID will become primary key. Now in guides, so we can take ID comma SID and we can make it primary key. But you see carefully. So ID and SID cannot become primary key. We'll see that why. So now we are creating three tables. One is faculty. So I am not discussing that. It is easy. So student is another table. Now we'll see guides table. In guides table, so what are the attributes we have to take? One is definitely guides information is about what? Which faculty is guiding which student. That's why ID, comma, student ID, comma, that's it. These two are important, right? So example, one student is, because we know that it is one to many relationship. Please recall, one faculty guides many students. That's why it is one to many. See, one faculty guides many students. Many students are guided by one faculty, correct? That's why it is one to many relationship. In that, if you see the data, you understand. So just try to observe the data. The data will be like this. Faculty 1 guides student, let's say S1, and maybe same one might guide S2. That means you need to repeat ID, remember it. But you never need to repeat SID, correct? You can write like this. So are you writing again 2 comma S1? Try to understand. S1 is guided by 1. S2 is guided, S1 is again guided by 2. That is not happening in this one to many relationship, correct? So that's why this many test side, whatever it is, student is not getting repeated. That's quite obvious to see because every student has only one faculty. If that is the case, then I can make SID to primary key. We never need to repeat it, correct or not? That's why usually in this case we make SID as primary key, but in many to many relationship we made combination of ID comma SID as primary key, but here we have to make that many side entities primary key as primary key. So SID never need to be repeated. Understand? Sir, if I make SID ID combination as primary key, what happens? Then you cannot repeat one again, right? When you cannot repeat a faculty again, how a faculty can guide multiple people? Understand? That's why. So only SID field should be primary key. So that we can do. So that is one alternative, but it's not compulsory. So what we can do is rather than creating 3 tables, we can go for 2 tables. So that is called minimizing the number of tables. What we do is we do like this: faculty table 1, second one student table. Of course we have already 2 tables, correct? Rather than guides, what we do is we move this guides relation to student side. The reason is convincing. Since every student has only one guide, then we are not wasting our space like we wasted in many to many relationship, right? No redundancy. The reason we will see. First of all, create faculty table separately. Don't move this student to faculty side. Sorry, don't move guides to faculty side. I will tell you the reason. We also do that. Before that, let's move guides to student and create a table called guide student. That means student guides. So in that you will have student IDs, student names as it is. Apart from that, you will have this relationship data. What is that? In relationship, what are the things you wanted to store? Student IDs comma student IDs. Already we have student IDs, then write ID, correct? This is the extra thing. If this relation has any descriptive attributes, we have to add it. Now you see, example, there is one student 1. Okay, so forget about this faculty information. If it is only student information, how could you store it? Student ID 1, student name Raju, correct? Next 2 comma Rani. But what now you are doing is you are simply adding the faculty name. One is guided by something, let's say, let's say faculty number 1. So 2 is guided by faculty number 2. Then we don't require to repeat the faculty information. The reason, because every student is having only one faculty. That's why this is quite easy, right? So this is second alternative. Here you require only 2 tables. Sir, why to move our guides relationship to student side? Why don't you move this guides relationship to faculty? Let's try that. For that, what you do is write faculty information and guide information. So example, faculty 1. Okay. Now his name is something Raju. Raju is very popular faculty and he is guiding thousands of students. If that is the case, you write 1 faculty name and now student information. So student ID. So student ID is what we can take student ID, student 1. Now we have to write 1 comma Raju, student 2. Why? He is guiding 1000 students. Then 1000 times unnecessarily you repeat faculty information. In this example, there are only 2 attributes. In general case, faculty table can have thousands of attributes. I mean, not thousands, at least 20-30 attributes. Then all such data will be repeated unnecessarily for every student, correct? That is unnecessary. 1 means Raju. Why to write 100 times 1 Raju, 1 Raju? It is unnecessary information, right? So that's why we never move this, I can say, this relationship to one side. Always try to move to many side. But when the relationship is many to many, if you move at any many side, you get same kind of problem, right? That's why remember like rules. One is in many to many, we cannot move the relationship to any of the sides. We need 3 tables. If the relationship is one to many, then we can move that guides to effectively many side. Understand? Now the third thing, if you have this kind of situation, which is nothing but many to one, it's quite symmetric, same thing. So what we do is we create a table for employee, we create a table for department. Since every employee is working for only one department, this is many sides. See, so we move works for to this relation to this employee side, because every employee is participating in the relationship with only one entity, correct? So like this example, employee ID, employee name, along with that we write department ID. This is one table. Second table is directly department table. I can say that department table is representing department information, employee table is representing, that means now it's no more employee table, it is employee works relation. That means we store all the employees and where they work. Now here we don't we don't require to repeat the information because every employee is working for only one department. But if you move works for to this side, you can understand if one department has 5,000 employees, then we should record them, right? Department 1, then we have to repeat all the employee information, then you get redundancy. That's why blindly remember from now onwards, for one to many and many to one, we are going to move the relationship to many sides simply. So only two tables are required. If you want three tables, you can have three, but with two effectively we can implement the same thing. Understand? You see one-to-one relationship. So if you have this kind of one-to-one relationship, boy marry girl, and you know that every boy is having some social security number, that is boy ID. So here also we are maintaining one social security number like Aadhaar card number, whatever it is, so that to uniquely identify the girl. When you have collection of boys and girls and marry relationship, that will be one to one. To know why it is one to one, ask this question. Every boy generally will marry at most one girl, and every girl will marry at most one boy, right? Usually. So that is what our understanding. If that is the case, it will become one to one relationship. How to record this one to one relationship into tables? So for that what we do is, we create first of all boy table. One general model is create a boy table, create a girl table. That means for every entity definitely at least one table is required. So that's why I can say that boy one table, girl one table, and you can have separate table for marry. So where you can write only specific information about marriage. That means particular boy ID is going to marry some girl ID, correct? And sometimes it might have some descriptive I can say attributes. You can add them, but currently I am not taking. This is one way, but we can record same thing with two tables. What you do is, whenever you have one-to-one relationship, you can move the relationship to either left side or right side if it is binary relationship. So that means you can move to boy side or girl side, not a problem. Example, how to move to boy side I will tell you. In the same way you can do to girl side. So boy ID as it is copied and boy name along with that. So to hold the relationship data, we should write girl ID, that's it. That means key attribute of girl table should be moved to boy side, that's it. So the reason why we can do is because every boy is marrying only one girl, so we are not repeating the information. If one boy marry hundreds of girls, let's say, just it's a theoretical situation, then you will be repeating unnecessarily boy information, but that won't happen in this case. Similarly, you can move that marriage information to girl side. So that's why finally two tables are sufficient to record this ER diagram into tables, right? Now, so far we have seen four different types of relationships, right? One to one, one to many, many to one, many to many. Let's summarize. Whenever you have one to one relationship, then two tables are enough. And whenever you have many to many, then we require definitely three tables. We can't move relationship to the tables. The entity tables. Third one, if you have one to many or many to one, simply again we require just two tables. We don't require three tables. So with two tables you can manage, but the only thing is the relationship has to be moved to many side. We should remember it. So this is the way we convert simple ER diagrams with mapping cardinalities to tables. Now sometimes you might have this kind of constraint, full participation or partial participation. If it is full participation, how you ensure? Generally, if you don't do anything, simply if you create the table, then that will represent partial participation. But to represent full participation, what to do, I will tell you. Actually, what is full participation? We will see with some example. Here, consider this one. Employee manages department. Here, department side is full participation in the relationship. Why, I will tell you. Here, first of all, why it is one to many, we will see. So our assumption is every employee, one employee is managing multiple departments. That means he can manage multiple departments, and every department is managed by only one employee. That is what my assumption. If that is the case, it is one to many. Okay. So every department is managed by at most one employee. So for that we will have, first of all, we try to create the tables without worrying about this full participation constraint. only we just try to capture one-to-many relationship. For that, what we do, there are two methods. One is method number one, create three tables. One is employee table, second one is managers table, right, manage, third one department, correct. Now we can do one more thing, that is we can move relationship table to dash many side, correct. This is many side, department side. That's why we can move this managers to department. Then you will form another table, that is, let's say, manage department. It's a combination, I can say, right. We are having data of departments and relationship manage. We'll see what are the data we write in the employee table. Usually employee will have employee ID, employee name, let's say, just for simplicity. Here what we do is we write employee ID, who is going to be a manager of the department, and department information, department ID, department name, correct. So here I am assuming that this has department ID and department name. Employees are having employee IDs and employee name. That's it. So that will be easy for me to explain you things. Now, so this is one table, this is one table. So how I recorded this one? Since it is one-to-many relationship, I moved manage to department. Now we'll see how to maintain full participation. That means we have to ensure that so every department should have a manager. That's it. That is what my intention. First of all, we'll focus with this one, three tables. Whenever you create three tables, what we do is, so let's erase this one. In this model, simply we create a table with necessary things like by employee ID primary key. We know how to create it, right? So employee name. So what I do is I write create table employee, employee ID primary key, and employee name. Along with that, so what I do is, see, I have forgotten to tell you one thing. In every process, whatever you did so far, whenever you divide into tables, whenever you have a relationship, the attributes of the relationship should be foreign keys to some other tables. We will see that. Actually, I have forgotten to mention that point. So what you do is, from now onwards, whenever I write relationship table, in that generally we need foreign key constraint. I missed in while teaching you one-to-one, one-to-many, many-to-one, that things, right? So please remember, in there also we have to maintain foreign key. So that foreign key I will show you. Example, take this example. You have employee table. So we create employee table like this, employee ID, employee name. Correct. So create table, it's lengthy process, that's why I'm not writing it, but you should understand that we are going to create table employee with this employee ID, employee name, and remember we make employee ID primary key because that is mentioned in the ER diagram, and employee name is a string followed by, that's it. Let's close it at this moment. Now department, how to create department table? I'm telling, create department table and department ID, department name you mention, and where department ID is a primary key. Everything we do whenever we write create table syntax. After that we need manage. In manage, what you do is create table manage such a way that employee ID integer, manager ID, sorry, department ID integer, correct. Now this employee ID actually related to dash this entity set, isn't it? That's why to record that, because in your ER diagram you know that, so these employees are going to manage departments, but when you create three tables, then this relationship manage should have link to employee table and department table. That's why I want to say simply, this employee ID is nothing but which is coming from employees. We know that. Further we simply say that this employee ID is foreign key. Similarly, this department ID is going to refer departments department IDs. That's why this department ID should be foreign key. Then automatically what comes to your mind is, sir, but actually whenever I make something foreign key, that should refer primary key, right? You just check it out. Already we made this employee ID primary key, no problem. Similarly, this department ID is going to be foreign key, and which is going to refer department ID of department, but that is also foreign key. But this thing I did not mention when I explained you converting the tables prior, right? So there also we should do it. Okay, no doubt on that. Now so far what we did is we have taken a ER diagram and we understand how to create them into tables, and after that how to maintain the links between the tables using the foreign key. Now I did not discuss how to maintain this full participation constraint. That's it. I explained you how to record this one to one, one to many, everything, right? So simply whether it is one to many or many to many or one doesn't matter for us. So there is no impact on the creating the tables. But generally the only impact they create is when you have one to one kind of relationship, only 2 tables are sufficient. When you have many to many, we require 3 tables. Apart from that, everything is same. So but when there is a full participation, that means we should ensure that every department should have manager. That is the meaning of department is fully participating. That means every department should have manager. Then how to do that, we will see. If you simply create these 3 tables, what might happen, I will tell you. So maybe user writes this kind of data, 1 comma Raju and 2 comma Rani. You allow it, correct? Because you know it's following the conditions. Now department, someone can write like this, department ID is 001 and department name is something like A, department 002 and department name B, in that way. Okay, now you see manage. What is the, I mean, in manage what are the attributes we have? Manager ID, that means employee ID comma department ID, right? So usually you will try to write some data, but since this table doesn't have any primary key, we have to create primary key, correct? So before creating the primary key, I will tell you one thing. What if someone writes like this, department ID 001 and employee ID null? We should stop it, correct? What's the problem with this one? This information says that department ID doesn't have any manager, but we know that every department should have full participation. That means theoretically, if you see the ER diagram, you know that every department has a manager. We should ensure it, then only it is full participation, correct? But there is a chance that if you create 3 tables as it is, but if you don't do something extra, then this kind of mistake people do. That means to ensure full participation, what to do then? Then what we have to do is null should not be allowed, right? Then we'll make employee ID not null. That's it. If you create employee ID as not null, automatically that will be ensured, right? Then from now onwards, no one can write null values. Now one more issue is, so here actually department's participation, otherwise department and employee are having one to many relationship, correct? So how to ensure it? That means department should not be repeated because every department has only at most one employee. How to ensure that? So that we have to take care. So if you take care of that, then almost things are done. So for that, see, if you don't make department ID primary key, what happens? So people will write again 001 one more time. There is a danger that they will write something 3. Now what happens? Then it is like department has multiple managers, right? That is not possible, because we know that when we are constructing ER diagram, we know that it is one to many relationship. So that's why to record that small subtle information, that's why we make department ID unique, otherwise primary key. If you make department ID primary key, then one to many relationship will be maintained. Understand? That's why in other examples also, when we were converting, so we always made many side primary key as the primary key of this table. That's it. Understand? From now onwards, you remember, whenever you convert a table into 3 parts, let's say, or 2 parts, whatever, then in that relationship, in the relationship table, if you have, then definitely the many side attribute should be primary key. If your relationship is many to many, depends on whether it is one to one, otherwise one to many, otherwise many to one. Let me summarize. Example, let's say your relationship type is one to one. You tell me, whenever you create a marriage table separate, then what to do? Then on that, what should be the primary key? Because every boy is going to be repeated only one time in the relationship, and every girl also has to be repeated only one time. You can take boy as a primary key, that means BID, otherwise GID, anything. That means in capturing the one-to-one relationship, if you create the table, I am talking about such table. Example, this is one-to-one table. Then definitely the primary key should be either left side tables primary key or right side tables primary key. Done. Now if the relationship is one to many like this, then the primary key in the relationship table is definitely should come from many side. If it is many to one, same story, right? Now many to many. If your relationship is many to many, then if you create definitely how to create a separate table. For that separate table, then we have to take primary key from employee, I mean this left side table and right side table, and together that attributes together all together will become primary key of the table. That's it. So if you do that, automatically that mapping cardinality will be maintained. Now by making this employee ID here null, not null, sorry, then we ensured finally this, what is that, full participation. But still it's not fully maintained. There is small issue, I will tell you. What is that issue is, consider this situation where you are having employee ID, employee name, here employee ID, manager ID, and you are following all the conditions whatever I told so far. Employee ID not null, manager ID is primary key. See this situation. So, and one more thing, you know that this employee ID should be foreign key and this manager ID should be foreign key of, see, sorry, this is department ID, right? So this department ID should be foreign key of this department ID. Understand? Now, see this situation. There are three departments 001, 002, 003. Their department names are A, B, C. Now here there are three employees 1, 2, 3 and their names are something X, Y, Z. The situation is like this. So I just follow all the conditions by write simply 1, 001. I write 2, 002. I don't write 003's information. Yes, it is allowed, right? So far I am following the conditions. What is mistake? According to my conditions, I cannot write null on employee ID. That is what you said. So that is what the condition you put, right? I am following. Then I can't write null. I am not writing. Now in department ID field, I should not repeat the data. I am not repeating. But what is the mistake I am doing? I did not write the data about 003. That means whether 003 has a manager or not, you are not able to capture. For this table, that means for this data, according to your constraints, it is a valid data. But this valid data is not capturing your ER diagram. What is your ER diagram's essential condition? Department should participate fully. That means every department should have manager, but here I am not able to do that. How can you ensure that 3 is also having, 003 has a manager? You are not able to restrict you, that you are not able to put that condition. Think about it. For that, what to do? So that's why what you do is, the strategy is, don't create separate table, because it is one-to-many relationship, right? At least in this one-to-many relationship, what we can do is, so create a table employee separately and create a big table called manage and department. Let's say manage department. When you have this table, and I'll tell you the conditions. One is, here employee ID primary key. Yes, we can do it. Here department ID is going to be primary key. Yes. So in this manage department, you will be having employee ID also. That employee ID is going to be foreign key, which refers this one. Okay. So employee ID, we put that it is not null. When you do that, then from now onwards, no one can write null. Now see, whenever anybody wants to create a department, how they create, you see now. Let's say new department created, that is department ID 001. When you enter department information, then we have to write manager information. Sir, I don't write. Try to do that 001. I write, sir, null. That's it. But null is not allowed. Something you should write. That means whenever you create a department, we cannot create that without the manager. In that way, definitely in this model we can ensure. That's why I can say that we have an advantage of creating 2 tables over 3 tables, when especially for one-to-many relationship or many-to-one relationship. Even for one-to-one also I can justify that. Understand? So this is the way. Now here definitely full participation can be maintained. Recall what is full participation. Every department should have manager. Definitely every department will have manager, no doubt on that. But be careful. So we cannot, since we cannot have null values, then it is a foreign key thing, right? So on delete set null cannot be used. Whenever you use on delete set null command, please recall. So that is not allowed here. It will give error. The reason, you are not able to, you are not allowing to write null value into employee ID, right? Automatically, that is an error. So that is what a small restriction on your tables. That's it. Correct? Somehow you have to manage it. Now apart from that, everything is pretty clear. So in the GATE exam, what they ask is they ask very fundamental questions. Whatever the theory I told you, you just remember it, and how to reduce the number of tables, you understand it, and understand the necessity. Why sometimes I cannot reduce the number of tables, especially for many-to-many. If you understand the reasoning, then it would be very easy for you to answer any GATE question. Understand? So this is the way we usually ensure all the conditions which are mentioned in the ER diagram, and we are converting them to tables. Finally, let's summarize. So you realized how to create the ER diagram, and you know how to maintain the conditions like many to many, one to many, that kind of thing. Second type of condition you can mention in ER diagram is this one. What is that? Participation constraint. After that, you know how to create, how to put a condition that, primary key condition. These are the typical conditions you can write on the ER diagram. Once you write such kind of ER diagrams, we can directly convert them to tables I explained you. So whenever you want full participation consent, we are using not null, correct? And whenever you want one to many or many to one, whatever it is, one to one, then for that definitely what we are doing. So this many side tables attribute, that means I'm talking about relationship. Whenever you have a relationship, if you want one to many on that relationship, make this many side tables primary key as a primary key of your relationship. Automatically this one to many or many to one or one to one can be ensured. Understand? So this is about finally all the conditions and creating the tables with that conditions. Okay, now we'll see one more thing, how to convert this kind of class hierarchies into tables. It's quite easy, that's why, so we can easily understand it. Example, so this superclass employee is divided into subclasses full-time and part-time. So here this full-time employee has salary and part-time employee has a special attribute hourly wages. Now employees, the common properties are employee ID, employee name, age. Let's say I can make employee ID primary key. So how to create a tables for it? Say method number one, what you do is create a table for employee separately and only write these attributes, employee ID, employee name, age. Second table, create a full-time employees table, and here you only implement salary, that means only salary field. But just salary field, is it sufficient? No, somehow we should actually there are some other attributes also to be maintained, correct? So what we do is, so we need at least employee ID, otherwise just salary if I write, if I create the table, will it be sufficient? No. Along with salary, what we do is we take employee ID, employee name, age. So in that way, so probably employee ID, employee name, but employee ID, employee name, that is unnecessary because already we are creating employee table, right? So that's why only employee ID will be the good idea. What you say, right? So that is one table. Third table will be hourly wages. In that hourly wages, what we do is create, it's attribute, right? Part-time. So for part-time, create a table and attribute will be hourly wages, and one more thing is employee ID. That means finally this table should contain employee ID, primary key field of superclass, along with that this special attributes. Similarly here also employee ID comma hourly wages are so table attributes, right? Part-time is the table name and attributes are hourly employee ID comma hourly wages, something. That's it. So three tables. There is alternative strategy, that is rather than doing this one, only create two tables. One is full-time, second one part-time. Don't create employee. When you don't create employee, so what happens is you are missing this information, employee name, age, correct? So what we do is here itself we write it, employee ID, employee name and age, salary, one table. Similarly here employee ID, employee name and age comma extra column hourly wages, another table. In that way, so we can have, unnecessarily of course we are repeating this field employee name and age here and here, correct? So that is second alternative. In that way we can go for any of the alternative. Let's summarize. Alternative 1, create three tables. One is employee, second one full-time, third one part-time. Attributes of full-time are salary comma employee ID and attributes of part-time are employee ID comma hourly wages. Now of course, so some other details I missed, that is here if I take employee ID as the one of the attribute, this employee ID should be foreign key of this table, correct? This foreign key, employee ID which is foreign key, we should refer this employee table. Similarly, this employee ID should be foreign key, right? That is one method. Second method, only create two tables. One is full-time, part-time, when there is no employee table, just two tables like this, and copy all the attributes here and here, then you don't require any foreign key, nothing, right? So this is one more way. In that way we can create two tables. right? So this is about converting class hierarchy. So far we have seen binary relationships, isn't it? So sometimes what happens is it is more natural to have more than two entities in the relationship. So example, see this one. This is ternary relationship. Here there are three entities participating in the relationship, correct? So here employee is managing the department and the department is in some particular location. So one employee manages a department in the location is the idea. So let's say employees are E1, E2, E3 and department is having some departments, development department and testing department, and locations are, let's say, Hyderabad, Delhi, Mumbai. So this is the data just to imagine clearly. Now see, the problem is how to maintain the constraint, that's it. So full participation, partial participation is quite easy here, but only thing is mapping cardinalities. Let me focus on mapping cardinality. That means how to maintain, I mean, is it one to many or one to one? So how to understand it is a question. So example, if there is an arrow for only one entity, then it is straightforward. So what we can understand from this is department, example, there is no location. How you understand it? Every department has at most one employee, but we have now one more entity, right? Location. That means for every department, for every location, there is at most one employee. That means I can say that this is, let's say, relation A, this is, let's say, relation C, this is, let's say, relation B, then AC combination is having at most one B. In normalization theory, this is nothing but AC determines B. So we have constraint that can be converted to AC to B. That's quite easy to understand, correct? For every department and location, there should be at most one employee. Example, development is the department and let's say Hyderabad is the city or location, then there should be, for this one, there should be only one manager. Similarly, if I change, this A value, which is nothing but testing, for testing and Hyderabad, again there should be only one employee, not more than that. So that is what the meaning of this one. But when there are multiple arrows, that means there are two ones, one many. Then there are multiple ways of understanding it. In theory also, there are so many ways we can, there are two ways to understand it. One is for every, let's focus on this one. The first way to understand this one is for every A, for every C, there is a B. I write like this. For every A, C value, there is a B. So done. I understand this one. Now I try to understand this one. For that, at that time, I don't take this one. I don't consider this arrow. So I'm just considering this arrow and I'm understanding. For every department and employee, there should be only one location or at most one location. That means A, comma B should uniquely decide what is the corresponding C. So this is one way of understanding it. So when you have these two rules, then that is one understanding. There is second alternative. How to understand in alternative ways, of course that is different. The second different way is simply take the arrow and see, for this arrow there is a one more arrow, right? So what is non-arrow thing? That means entity, this one A, right? So we do like this. Department which doesn't have arrow, that is going to connected to employee. That means we understand like this. Department has at most one employee and department has at most one location. That is the second way of understanding. That means every department has at most one employee. At that time I am not considering this arrow and this entity. At most one employee. Second one, every department has at most one location. So this is one more understanding. So when there are multiple arrows in ternary relationship, the problem is there is no one way of understanding it. There are multiple ways you can understand it. There is an ambiguity. So yes, there is an ambiguity. We can't solve. Don't expect every time to have an ambiguous way. So students think that every time we can solve the things. That means so they ask, so what sir? Finally what to do? They ask. We can't do anything. There are two ways. Either you have to either understand in this way, otherwise you have to understand in this way. It depends on the agreement. Example, let's say two people are talking about this diagram. Then first of all they should decide what is their understanding. Do they want to proceed with this or do they want to proceed with this? They should first of all come to a common agreement. Then after that they have to discuss. Understand? So there is no unique way. So otherwise what happens? Raju says that I am following this one, this is the correct. Rani says that no, I don't follow you, I follow this one and I am correct. So always that will end to, I can say that, nothing. That's why, so when there are multiple ways of understanding, that means multiple definitions, I most of the time try to avoid it, correct? Otherwise, what happens? There will be a split. Some people say that this is correct, some people say that this is correct. But in fact, there are two ways we can understand it, correct? That you remember, that is more than sufficient for us. So in the GATE exam, if they give that kind of questions, just try to understand using your knowledge. First of all, try to guess whether is examiner's intention or examiner is using this model or this model. From the problem, you can try to gain that thing. You cannot gain anything. There are two options. Example, in multiple choices, if you take this method, you are getting one option. If you take this method, you are getting one option. Then definitely we cannot solve that problem. That problem will become ambiguous. Now finally, let's summarize. Whenever there is a ternary relationship, then when there are multiple arrows, how to understand that I will tell you. First of all, method number one, what you do is, so first target this arrow and take the other two combinations, whether it has arrow or not doesn't matter. So I am targeting this arrow. So I am describing this arrow. Every department location has employee. Done. Now I am targeting this arrow. For every department and employee, at most one location. This is understanding. Now second method is, first of all, so identify the arrows. This B has arrow, C has arrow. Which entity is non-arrowed entity? This one, right? That means many side. Target this one. Start here. So first of all, A versus B. Every department has at most one employee and every department has at most one location. That is another understanding. So both are correct. That means, of course, both are different, but one of them we have to follow. But so definitely it is ambiguous. Somehow you have to avoid. That's why most of the books, what they do is, they don't allow this kind of terminology. That means they don't allow to have multiple arrows. That's why some of the authors only discuss things with only one arrow, and they restrict themselves to unambiguous things. But some of the, if example, if you encounter some problem with this kind of multiple arrows, then there will be two kinds of notations possible. So go through two of them and try to fix the answer based on the options. That's it. Okay.